Hi, everybody. Welcome. I'm Sudha Kumar. I'm the director of the USC Viterbi India office. And today I'm so excited to bring you this unique and very useful panel discussion to you. If you are considering a career path in civil engineering, you will find this helpful. So our panelists are pretty amazing, and we are very lucky to have them spare the time to join today. Dr. Lucio Soibelman is a chaired professor at USC Viterbi. He worked as a construction manager for 10 years before obtaining his PhD in 1998 at MIT. He was a faculty member at UIUC and at CMU before he joined USC Viterbi as the chairman of the Civil and Environmental Engineering Department. And during his tenure, he really transformed the department. Among his very long list of honors, a few highlights are: he is an ASCE Fellow, an ASCE Distinguished Member, a member of the National Academy of Construction, and a member of the Pan American Academy of Engineering. Welcome, Lucio. It's always a pleasure to interact with you. Our second panelist is Joao Carneiro, and he's a civil engineer and he's an alumnus. He came to USC Viterbi to do his master's program. And during his master's program, Joao was introduced to building information modeling and other concepts widely used by American contractors. At the same time, he was introduced to research and joined the PhD program. He focused on occupant lighting choices, data visualization, and virtual and augmented reality. After 3.5 years, he dropped out of his PhD program and returned to the construction industry. He joined Balfour Beatty Construction to be one of the Los Angeles International Airport automated people mover, BIM contractors, coordinator, I'm sorry. Joao is responsible for coordinating 2 stations and all pedestrian bridges that connect the APM stations to the terminals. In this project, Joao oversees 4D simulations, virtual reality, snapshots for public engagement campaigns, and the creation of custom scripts to reduce the amount of manual work. Aside from his dedication to the APM project, Joao has started to implement and manage a virtual asset library between all of Balfour Beatty's virtual design and construction offices in the US territory. He believes that construction industry is ready for big change and disruption. Welcome, Joao. We are so delighted that you could join.
Thank you. It's my pleasure.
Thank you. Before we start, just a few housekeeping announcements. We have received many questions as part of the registration. We will attempt to address all of them that relate to the topic. If you have additional questions, you may type them in the Q&A section, not in the chat, please. And time permitting, we will get to them as well. So without any delay, my first question is to you, Lucio. What do you see as the future of civil engineering, both globally as well as within the US?
I think that we are in a moment that is a changing moment, that it's going to have a huge impact in industry. This is already happening in other industries. People talk about AI. I would say much more about data-driven. We have a very, very data-rich environment today. In the last 20, 30 years, we've been acquiring data about all our processes, have big databases, and things increased a lot with building information models. That is, for me, just a data repository that you have information about every object. Considering that, I don't believe that you're going to be doing, at least we think in structural design, in maintenance and operations and construction of facilities, you are not going to be doing the way that we did in the past. You see this in other industries, the financial industry. You don't have humans doing stock market analysis. In the law industry, you don't have lawyers doing jurisprudence analysis. I believe that in engineering, you are not going to have engineers doing estimates, schedules, and the things that we do today in the traditional engineering. We are going to be using this data-driven approach, AI, machine learning, being able to predict the duration, the cost, the processes, using past examples, past projects as an example. So I think that the industry is moving much more into robotics, AI, and so the background of the civil engineer, it's not just math, physics, but computer science now. It's an integral part of the process in being a civil engineer. So this is changing the way that we teach, and it's changing the way that companies are going to behave in the future. So I think that you are in a moment that everything is changing, and you have to be very careful not to graduate what I call students that are going to be obsolete very, very soon. You have to build the workforce for this future that it's coming.
Yeah, I realize that, and that is the purpose of this panel discussion, because I think students need to know where this field is going. Joao, did you want to add something to what Lucio said?
No, I 100% agree. And for what I see in the industry, there is a lack of understanding of data-driven approaches and what is AI and what are those things. And if you come with this knowledge, it definitely is going to help you not only to get a job right now, but to help you in the near future. And that's really, really important right now, because people don't understand what is the data-driven approach, and they have a really, really old way of thinking. So more and more people that we get that understand what is a data-driven approach is and the importance of it, it definitely gonna give you an edge as a career, but it also would greatly help the industry moving forward and keep doing this change that is happening.
Okay, thank you. Lucio, when we talk about AI and machine learning, can you give some examples of how that is being used in the construction industry?
Several ways. Okay, for example, I even wrote a lot of articles, and I did research more than 20 years ago using database from the U.S. Army Corps of Engineers, using their own databases to find the reasons why their projects were behind schedule. So you are able to do a cause and effect and find out that it wasn't the weather that was delaying their project, like all engineers concluded by their experience. And when you look at their own data, you are able to find out that they had the excavation and problems with boulders that they had to remove that was delaying their project, just by looking at their own data. You have a company here in LA that came to me with a project that they had 2 towers, okay, exactly equal, twin towers, okay, and they started both towers at the same time. One tower was in the 12th floor and the other tower was in the 3rd floor, and they had absolutely no clue why one tower was going much faster than the other one. They had the same managers, the same crew, the same workers. One was going much faster, and they had the data, and they didn't know how to look at their own data, what's going on. So again, you used machine learning. You look at the reasons was the feeding of materials, and the supply for one tower was not at the same level as the other tower. Wasn't related to engineering, wasn't related to crews and to workers, was just the supply chain in one of the towers was deficient. Again, but they didn't know. It's just by looking at their data, they were able to do it. When you look at BIM, we are integrating, you're using machine learning to integrate information into the model. We have a startup company from a collaborator, a good friend from Illinois, that it's flying drones and creating real-time 3D models of construction and superimposing with BIM, with the scheduling BIM, and automatically telling how much the project is behind or ahead of schedule without doing any measurements, just by flying the drones. The same company can fly the drones on top of inventory and, and tell in real time how much sand you have in the pile. Okay, it's pretty difficult to measure sand and say, oh, you have this volume. So he can give a very high number. He can give productivity into excavation just by measuring the size of the hole every 5 minutes and using a lot of the image. So again, why is this machine learning? This is basically computer vision. Computer vision uses machine learning, transforming the images in pixels. The pixels is a matrix, and you can do all the analytics that you want to do it using deep learning and other tools. I did research to the Army that we fly drones to the Army and you create 3D models of a war zone in real time. And then the soldier is able to, in a very palm-like device, put a sniper in a building, and the computer can tell them how to go from point A to B without being seen by the sniper, how they can hide and not be shot. So if my research is wrong, soldiers are going to be killed and I'm responsible. So I don't sleep well at night with that. But again, all those kinds of things are changing the way that you build models, the way that you do analytics, the way that you learn about our schedules, the way that you predict the cost of projects. All these is being done now with tools and data, and again, machine learning. It's a way of dealing with this large amount of data. So there are hundreds of examples, not just in academia, but a lot of companies. I'm a member at a very important committee at ASCE that it's basically just industry people. I think that I'm the only academic, and they are discussing these examples of things that they are doing non-stop for structural design. Everything that's very repetitive, it's being replaced by data-driven approaches. And structural design has a lot of things that it's very repetitive. So those companies are using a lot of machine learning in their processes too.
Now, do you want to add something to this? Any good example that you'd like to give?
What I see the most being used right now is monitoring tracking and computer vision, as Lucio said. You often give cameras to the workers and let them take pictures of the construction site, and that becomes a model compared to the BIM model to make sure to monitor the progress tracking of the construction, but also to have you a visual library later on in case you need to go back to find out where things are. But the most important thing is the monitor tracking, and how you can do those things really helps us on determine which state you are in the construction way better than going back on the piece of paper and mark the checklist, and then you give back to your scheduler for him to mark. So that's, I think, one of the biggest things that I have seen right now. There's a lot of other approaches, but I think Lucio covered all.
Yeah, that's wonderful. So actually, the next question goes to you as well, Joao. How is augmented and virtual reality being used in the construction industry?
Virtual reality is mainly being used as a tool to communicate with the stakeholders. For example, we have a QR code virtual reality snapshots of the project that we release to the public. That it's really important to engage the public, but also to show our client how things are gonna look like, how they're gonna feel once they're inside of the station. And we definitely took advantage of this too on showing the design and let them understand what was our plans at the time. Augmented reality is still relatively new, and it's mainly it's not new, it's just like has a issue with the screens. So the way that the screens works, they're reflective, and under the sun they're not that great. And until that technology changes, I think that's when you're going to see it kickstarted. but it has been used. You have seen companies using for a lot for giving instructions to workers or having a conference call while they are working and getting help from a more experienced person for when they are not in the site and both can try to work to drive a solution. But inside of construction site, it's a little bit hard because of the reflective panel of the technology. But it's getting there. You have seen the platforms being created, and I think it's just a matter of time until they fix that issue.
So that is something that'll be more prevalent in the future.
Yes.
I can give some examples too. For example, sure. Augmented virtual reality, there are companies that use it indoors. We call it X-ray vision. Okay, so they use, and then because it's indoors, they can see, for example, inside the wall after they install the water distribution pipes. Okay, so you cannot see it; it's inside the wall. So you can use augmented reality to see where the pipes are. If you have to make a hole to install another thing, not hit the pipe. The Caterpillar, it's using augmented reality in their excavators that they can see in the screen inside the equipment. They can see if there are pipes, if there is gas lines. That's a big problem. Excavator heating gas lines and having explosions. So they can excavate and they can see underground through that augmented virtual reality. They are seeing the ground and the underground in the screen. The use of virtual reality, it's being used all over the world. I visited a company in Brazil and another one in China doing the same thing. Those countries, it's very common to sell buildings, apartments before they even start construction. So before they would build in the floor what you call model condos, where the buyer would be able to see how the condo would look like and would see the bedrooms and would see all the characteristics of the condo for them to buy. So this would cost millions of dollars to build the 3-bedroom model, the 2-bedroom model, and all those things. So now they bring the potential buyer to a virtual reality, either cave or goggles, and the person can walk in the apartment and see how the apartment is going to look. You can show the view from the first floor or the view to the apartment in the 35th floor. You can see that you cannot do it the ground, the built model in the ground. You can allow the user to what happen if I decide to transform this 3-bedroom in 2 bedrooms and I remove that wall. You can see automatically the difference. You can see what's the difference of having a marble floor with a tile floor. You can customize and let the user interact with the apartment in different ways. So this is being used all over. Virtual reality, what else? For example, in my research team, we developed a virtual reality to train construction workers to operate construction robots. And it's very expensive. And you learn that the workers, when they are trained in the virtual world, they are better than the ones that are trained with the real robot. And what we did, you allow the person to push the robot to the limit and to break the robot in the virtual world. And in the real world, that equipment, it's millions of dollars. So the user, it's very concerned of using it. So it goes very slow and everything. In the virtual world, they really can see the limits of what happens if they incline in a ramp, if this robot collapses. And it's the same thing as flying a plane that the pilots are trained in the simulator, the flight simulator. Okay, they can train without removing the tires, with a hole in the plane. They can do all things, and they can crash land 100 times before they they don't die and they don't destroy a plane. So they can do things that they cannot do with the real plane. And you are seeing that you can do those kinds of training in construction, that they can understand the bad consequence of their actions. You cannot train in the real world and let them kill people. Okay? But so there are a lot of things that are happening with virtual reality in training, in sales, in analytics for sequence. You can in virtual reality find that if you assemble something that sequence, you are not going to be able to reach the screw anymore. So you should put the screw before, and then you can go in the virtual reality and do a mock-up construction of a complex area and find out the perfect sequence. So there are hundreds of things happening with virtual reality.
Yeah, that's wonderful. Actually, you brought up the topic of robotics. How prevalent is the use of robots in construction nowadays?
It's happening a lot and very, very fast. The main problem with robotics, and we had a lot of use of robotics in construction in early 1990s in Japan. Obayashi, Kajima, Shimizu, they really pushed the envelope and they added robotics. One of the biggest problem of robotics of that time was to program the robot. If you had a robot to paint a wall, you have to tell the robot where the wall starts, where the wall finishes, how long it's the wall, the coordinates of the wall. So you had to have someone extremely expert on robotics to be able to define the task that the robot would need to do. This all changed now that you have prevalent use of BIM. So you have a perfect 3D model that is a program of how the building looks like, and it's the sequence and how it's going to be built. And so basically you just add that information into the robot, and the robot has the whole characteristics of the product that has to be built. So programming got much, much easier. We have a lot of robots now in things that are today dangerous. This is the first groups of robots that are being brought to industry. You have a lot of what we call demolition robots. It's obviously that if you want to demolish an old structure, you're sending a human there, and any mistake, the structure fall on top of the person and kills the person. So those demolition robots, if anything wrongs happen, they collapse on top of the robot, and okay, you lose money, but you don't lose life. So you have a lot of painting and things that needs a scaffold and high. Those are the first generation of robots that are going to industry. The difference is that they are not completely autonomous. They are many of them are teleoperated. So you still have the human, so it's not replacing. So the acceptance, it's not a problem. So workers are not seeing those robots as replacing them, but as a tool that augments their capability and increase their safety. So those are the ones that are being accepted both by workers and are being used today in construction. But we still have problems. You have problems because unlike the assembly industry in an automaker like Toyota, majority of the robots in those other industries, because you have an assembly line, you can isolate the robot from humans. So you can have a station, a welding station, that the car arrives and the robot it's welding the chassis wherever of the car. You have a cage around that robot and humans cannot get there. And then after the robot do their test, the car moves to the next station that can have a human or can have another robot. But in construction, because construction is fixed and the workers move around, if you have a bricklaying robot, you always are going to have a carpenter, someone else walking around, because you have so many crew professionals working around the same space. So the problem that you have with robotic in construction, it's not to train the robotic operator, but to train the people that are around the robot and can be hit by the arm of the robot moving. So you still have to find a way how you train the whole construction crew if you bring a robot, even if it's doing just one small task. So these are some things that we are working a lot, but there are a lot of things going on. You have a lot of 3D printing today. You guys are seeing the media, robotic welding. We have a lot of robots in construction for many, many years. When you do prefabrication, when you do trusses and structure that you move to the construction. So it's just a question, is the robot in the construction or is in a plant that it's building components for construction? So that one, it's safer because it's in a plant, it's isolated from workers, you build a truss and then you bring the truss to construction site. But again, when you think about cranes, those cranes that you have today, they are robotics too. So yeah, there are many things going on.
Wonderful. Yeah, you talked about 3D printing. So how is that impacting construction? Are people beginning to use that a lot, or is it just for some small emergency type construction, or how is 3D printing impacting?
It's an interesting question because 3D printing was invented here at USC for
That's right.
concrete. Was developed by Barak Neves, one of our faculty. And Barak now is the CEO. He's still a professor, but he's on leave because he has a startup that it's very successful called Contour Craft. And we just bought one of his equipment. So he changed from being a construction guy that wanted to use the robot to be just the 3D printer manufacturer. And so universities like USC and others are buying his equipment, and we are looking into how to use 3D printing. I am a little bit of, I have some issues with 3D printing because as is today, it's a lot of marketing and talking, and that's the future. Because I came from industry, in my experience, building the construction envelope is the easiest part of the project. So putting up the structure and building the envelope, for me, in my company, was less than 20% of the effort. Okay? The effort was really painting, installing the pipes, and doing carpeting, and putting the windows and all the finishings. This is 80% of the construction. So I think that the 3D printing just prints the envelope. Okay? So it's not really the solution that everyone is bragging about, because you print the envelope, but still you don't have water, you don't have electricity, you don't have outlets, you don't have tiles, you don't have flooring, you don't have anything else, not even roofing. They are not printing the roof, many of those solutions. And when you go to sustainability, cement, it's one of the less sustainable materials. So again, I think that you have a long journey to go, and we have a 3D printing lab that you are building here in the department with equipment from Contour Craft that I said. You are looking into it. We as an academic, we always need to look at those things, teach our students about those technologies, but I am always a critic of all the bragging that people are doing in the news, like this is the solution for all our problems.
Okay, no, it's very interesting perspective, Lucia. So the next question I wanted to talk about was advanced materials, the cements and all the things that go into the construction. What is the latest in those areas?
So if it's me again, for me, the latest is the oldest. I'm a big fan of wood, timber, okay? Because it's sustainable. You can grow it, okay? Every other materials you are using until we don't have it anymore, okay? So if you are using steel, you need iron ore, and the world doesn't produce iron ore. Okay? We use it, what we have, until the moment that you don't have it anymore.
Right.
Okay? Cement needs a lot of energy. Now, energy to produce the cement, you need to burn burn oil and oil it's finito. You're going to use until we don't have it anymore. So everything that we extract, we are reducing the availability for future generations. Wood and timber is the only thing that we grow and we use, and you grow it again and you use it again. Okay, so it is a very low carbon footprint. You see now in Europe, in a lot of countries, high-rise structures using timber. I am a big fan of going back to the simple and learning from the past and looking at the future in a more interesting way. But there are a lot of materials going on. There are again a lot of new structures that you couldn't create before by micro level of nanotechnology and printing at the nano level. We have a professor, Kim Wong, that created this, the first material that shrinks with heat, okay, by using molecular level of 3D printing. So there are a lot of things going on with materials. We have Professor Bora Jenturk. He is a professor in the structures group. He is a huge expert in very high strength concrete, extremely high strength concrete that use fibers and other materials on it. These obviously that it's going to be much more sustainable, because if you can increase the strength of concrete and reduce the amount that you use of cement, you would be able to build higher and taller structures and stronger structures using less material. The main problem that we have with those materials, that you have a lot of research and a lot of other universities working, is that we can get high strength concrete, but those materials are very brittle. So they have strength, but in an earthquake they would not have the behavior that you expect. So this is Bora's work. It's really finding the high strength, but still increasing decreasing the brittleness of those materials and make it more earthquake safe materials. So there are a lot of things going on in several universities about new materials.
Very good. So Joao, my next question is to you, and I'm going to kind of shift the conversation a little bit. Tell me what made you go back to construction engineering? What makes you passionate about your field of employment?
Oh, wow. That's a loaded question. I love construction. I love construction sites in general. I like the excitement that it is stressful sometimes, but I was missing that stress in my life a little bit during PhD, and that's why I had it decided long ago that I was going to go back to the industry. What excites me about construction is the ability to build something and see it. I love the fact that I can get the drawings, the beam models, and I see what is happening. I see how it's happening, how everything needs to align in a certain way. Just like a symphony, everything needs to come on a certain sequence for everything to work properly. I also love the challenge of the change, and that's what drives me, and that's why I keep engaging on the conversations just like this, because I do believe we are ready for change, and I do believe we are way past due for change. And that's one of the things that excites me, that I try hard to do, and excites me to get every morning up and discuss the issues and discuss bringing change and how we can change and what you think, and try to explain how thing works. And yeah, and as a BIM coordinator, what I love the fact that I can save a lot of money. I love the fact that I'm constructing before construction happens. think that would be the phrase that I would say, that I'm there, I'm looking at the design, I'm analyzing the design, I'm analyzing what the trades give us and tell them, hey, this looks wrong. Can you please redo this? What do you think about this? Can you redo this? So just the ability to be ahead of construction and then go back and see how your decisions impacted the design and the construction as they're building. Those are the things for me that kick in and make me want to stay in this industry.
Thank you. So when I listen to the two of you, it sounds like the civil engineering is not the same as in the past, you know, and not just the concrete and the mixing, but things are really, really changing. So how should a student who's currently maybe doing their undergraduate studies, how should they prepare themselves for the future? What kind of skill sets should they start learning, and how should they plan their career? Lucio, do you want to go first, and then you know, Joao, I'm going to ask you as well what your perspective are.
I will continue to João's answer to the previous question, and then I think that would link to your question now. What is happening is that you have much more computer science, electrical engineering through sensors and everything. So civil engineering, it's going into a direction that it's much more general, okay, bringing those expertise from other areas. The advantage of being a civil engineer from talking with the student is that people think, oh, computer scientists are doing the advanced things and civil engineers are building concrete bridges, okay? So civil is the past, computer science is the future. In reality is that both are doing the same things, okay? It is computer science applied to civil engineering problems, other is computer science applied to gaming, okay? So the difference is that the civil engineering today, it's pretty cool because you are going to be doing the cool things, but you are not going to work your life into a cubicle as a programmer, okay? You're still going to be doing programming, but we are going to travel to sites, see people, see the sun, okay? Be out, have different challenges, not do the same thing over and over again because projects have different characteristics. So what they love is that they are not doing things from the past. They are still doing things from the future, but they are doing an environment that's much better than the traditional computer science environment. Talking about that, what it's needed, it's needed to learn how to learn. And I think that this is the most important thing that we do here for our students. Today is BEAM, 2 years from now it's going to be BAM, 5 years from now it's going to be BOOM. Okay, it doesn't matter. Things are changing so fast. And the most important thing for anyone is to learn how to learn. You cannot come to a school in the US and be my student and learn BEAM and go to industry and say, okay, I know BEAM, I'm done. No, you're not done because it's not going to be BEAM 5 years from now. It's not going to be was neural networks for machine learning 5 years ago. Now it's deep learning and support vector machine, and those things keep changing, and you have to learn to change with the time. So you have to learn how to learn. You have to learn, and this is much more difficult today because there is so much terrible things in the internet. So now when you want to learn, you are overwhelmed by information that is not relevant, that's not important, that is people almost marketing about 3D printing, but how do you get your critical thinking to understand what is marketing and what it's real, how you evaluate technology, how you get depth in that technology. So this is one of the most difficult things to do today, and this is why our teaching here, it's very different in the US, it's very different in the rest of the world. Students sometimes get very frustrated because they arrive in our classes and they say, the professor is not teaching me. No, you are going to the library. You are going to learn how to do your research. I'm just a kind of a maestro helping you to learn, but the process is to learn how to learn. And this is the most important thing. If you can learn how to learn, you don't even need to come back to school. Okay? You can go and learn BIM, learn everything that you need and be ready for machine learning and read papers, and read articles, read books, and go and deploy those things. But it's good to come back to school to learn how to learn.
Good. Joao, what about you? Want to add anything to that?
Yeah, no, I 100% agree with Lucio. Learning how to learn, it's extremely important. And always trying to challenge yourself to improve and learn, it's extremely important. I would say that also is extremely important for you to understand the basic concepts of things. As I said, it has a really lack of people that really on construction engineers, in my opinion, at least on the construction sites, that understand what is a data-driven approach. It's almost like you need a middleman between construction engineers and data analysts to translate what each one is saying. And that's a job that shouldn't exist as long as you learn the basics. You learn how to speak both languages. And I think that's what is the future. It's understanding to speak and be able to change thoughts in a really good level between computer science, electrical engineers, how can you deploy sensors, how you can use computer vision to track, and having at least a basic understanding so you can leverage on that later on. That would be the only thing that I would say.
Okay. One of the people from the audience had a question saying, after I finish my undergraduate degree, should I go work in the industry for some time and then come in for a master's degree? Or would it be better for me to go for a master's degree before I join the industry? Would some work experience be helpful?
That's the billion-dollar question, not even million. I would say that it's a billion-dollar question. I will tell you why. Obviously, that if you go to industry and you understand the problems and you come back to be a student, you are going to be able to understand what it's important and understand the problems in a better way to be able to study. But that's a very dangerous proposition. It's exactly what I did. I got my undergrad, I got a master's right after the undergrad, and then I did work for 10 years before getting a PhD. And this is, I would say that it's one of the most difficult things that I did in my life, because I got married, I had kids, I had a company with more than 300 people working for me. I had a mid-sized construction company. How do you stop all this and say, I'm going back to school? Okay, and this is why it took me 10 years. It took me 10 years to convince my wife that I wanted to do that. Until now, she doesn't understand why I did that. But obviously, that gave me a huge advantage because I had a lot of understanding about the industry. I thought that I knew more about construction than any of my professors. Okay, and but I tell the large majority of the students that try to do that, life gets to them. They buy a car, they have to pay the car, they have to pay mortgage or rent, and they get a family, and then life, it's there. You are getting a very nice salary. You say, hey, that's comfortable. I have a salary. Why I'm going to give this up to go back to school? So majority of the time, it's very difficult, and I see that people regret the fact that they didn't continue with the education, and they couldn't come back to the education again later. So it's the question of the decision. It's not about so simple, say, oh, what's the best? You have life happening at the same time.
Mm-hmm. Joao, you made that transition to first you were working, Then you joined the master's program. And mhm,
My
go
path
ahead.
was a little bit different. I took the undergraduate as an opportunity to do many internships in different size companies. I knew that was construction for me, was an structural engineer, but my path as an undergrad was to do a lot of internships. So I did work 2.5, 3 years while I was doing my undergrad, and in Brazil is 5 years for engineer degree. So more than half of that I was working. It's tough. It's not easy to have both at the same time, but it's doable. And I think it's a great opportunity for you to learn and see what you really want to do after this and experience. And then I went for master's and then stayed for PhD. But yeah, I think my advice, it's like, as Lucio said, it's like, it has no right or wrong answer on this, in my opinion. It's just like, I took advantage of my undergrad to learn construction on the practical field. And I think that's a great way to do it. As you're learning on school, you're learning also on the field. That's what is my
I
path.
think that's great advice from both of you. As an undergraduate student, try and do some internships and try and get to the MS program as soon after your undergraduate program, just in case you don't have the kind of focus that you need and the determination to not get life come in the way, right, of our education. But Lucio, do you think a MS program, a master's degree is important? Especially now, I guess, with all the things that you talked about, with everything new that you talked about that's happening?
I do believe so, and there are different masters, and there are so many types of masters that the student can take. We have a master's here that is very industry oriented. Okay, we have the Master of Construction Engineering and the Master of Construction Management. They are basically taught by a lot of part-time lecturers, people that are from industry. USC, it's next door to the large construction corporations like AECOM and Turner and others. So they many of those high executives teach for keeping a connection to academia, but at the same time to be able to hire our students. So I think that it's a very strong masters for international students that want to be able to benchmark and compare their industry from their own countries with the way that's done in the United States. There are masters. We have another masters that it's just in robotics and the future of construction industry. That's much more academics. It's me, Burchin, David, really trying to push the envelope and to prepare the professionals for these. We call it creative change agents that are going to change the industry. It's a very different masters. You have masters in many universities that are really preparing just the students for PhDs. So you cannot generalize that a master. So there are so many flavors of masters, and this is important for the candidates to do their homework, talk to the students, and understand about what's the flavor of the masters that they are applying for.
So I guess the bulk of the audience is from India, and many of them are undergraduate students with no work experience. And if they were to transition to a MS in the US, either at USC or some other universities, can they find jobs without work experience?
Oh, that's a question that changes every month, okay? Because before COVID, yes, okay? There was, I would say that even before Trump as a president was pretty easy. The students would come, companies, the construction industry here was in ever high, that there was very huge problems of finding engineers. The companies were desperate for hiring. So they are willing to do the training and hire students. So this is why they were teaching our program. They would pick the top students and hire. So I'd say that 5 years ago, everyone was getting jobs. Then came more difficulties with visas and other things with the previous government. And so there are some students that are facing some difficulties with moving from the student visa to a working visa. But again, there was interest from companies. They still had the jobs, but there was more difficulties in that thing. João, it's one example, and was during that time, and he was able to get his working visa. Students have the practical training that it's enough time for them to change visas. And then came COVID that I really don't know how things are now, because many of our students are not here, taking classes online. Things are not normal, and I am expecting them to normalize. We are in a very strange situation. So I'm not saying, I'm seeing some students that graduated during this middle of this crisis that was the first time that I was receiving mails from students asking for help to introduce the company. Before, the students are all getting 3 to 4 offers, and the mail that they sent to me was, which one should I choose? What's the advantage of A against B? So the world, it's in the middle of a crisis. It's so difficult to understand how things are going to turn around. So I don't like answering this question, because I don't want students coming back to me 2 years ago, 2 years in the future, and coming back, oh, you thought it was easy, and it's not easy, because the economy can change, the market can change, wars can happen, COVID can happen. So many things happen during those time, but in normal situation, yes, it's very, very, very easy. And I think that João can answer about his example. He's not an American citizen. He had a student visa, and he can explain how easy or difficult it was for him to get a job.
For me to find a job was I can say wasn't that hard. I did get some no's on the way. It's normal. You will get no's. And I got on the end 2 offers. One of them was a friend that referred me to the LAX project, and I took it because it's a dream job, right? It's a job that you, as a civil engineer, you can just dream, because it's those mega projects that you see on TV, and you know that very few is gonna make it there. But yeah, that's how I found it. USC is great for that, because you have a lot of industry alumni coming back. So you have a lot of networking experience for you to do it. As a trend right now, things were really stagnant a couple months ago. I do think the tendency, and for what I see, the amount of emails that I'm getting from recruiters are increasing. So I think soon enough, if everything keeps going the way that they're going, everything tends to normalize, and the job market gets better again. But yeah, it's like we don't know what can happen in the near future. It's definitely the tendency right now is to become better. The job market get better, but its economy is definitely a unsure thing that can change. As visa situation, I think everyone needs to do their homework. It's a complicated process. Better you know, better your chances. My path was to take the OPT and then the extension OPT and keep applying for H-1B visa. And now I'm gonna be applying for the EB2, but that's a really niche path that not a lot of people can access. But again, a visa is tricky, is boring as hell, but it's homework. It's learn how to learn. It's like do your homework, learn, discuss with your lawyers. There's not much you can do there.
Okay, Very good. So, so I think for students at USC Viterbi, I think they're very lucky that they have a career center. So in tough times, I think the idea is to go and talk to the career center well ahead of time and start looking for jobs.
Not only that, we have many opportunities as companies come to the school, at least when the job markets are good, like they do events, they do presentations, you get one-on-one time with the people that are going to hire you. So do your footwork.
I can tell as a department chair, my biggest nightmare is the amount of companies that want time with our students. So I receive 30, 40 calls a day. Can I give a presentation about my company to your students? And these, I had to balance how much I would allow them to come and to market their companies and how much this would be distracting the students about learning, about their classes and everything. So basically, I can even, as a department, make some profit with that. I can charge those companies to, you want time, make a donation to the department, and it's crazy. They are really, this is one of the top programs in the country. So, and LA has such a large number of local companies, so or national companies that have offices in LA. So they are always around our students. Other thing that we have our construction and department alumni association, Wilson affiliates and the construction group, that they meet over and over and over again. So not just people hiring, but former students that can show the path and the way of doing things.
Right. Now let's hope that the industry goes back to its booming time. And then I know
I think that the company is still booming. The construction never slowed down with COVID. But again, the hiring, it's been very complex because it's difficult for them to, if they have their offices closed and they're doing everything online, it's very difficult to bring a new engineer and train them online. And so the companies are really trying to adapt and find a way of bringing their offices to normalcy again. And I think that they are waiting to hire because of the closed offices and everything, but the construction sites are moving and are moving with less engineers, and they are suffering because of that.
So I actually expect that there'll be a pent-up demand for people later on if the COVID situation clears. Yeah. So in terms of training, what kind of software should a civil engineering student learn to prepare? I know you said they have to learn how to learn, but would it help if they were proficient in any particular software?
Obvious that you have. It's a tough question. Obvious that Revit and Primavera and the other things, but I was as you said when you introduced me, I'm a member of the National Academy of Construction. So this is basically the CEOs of large construction companies and 1 or 2 professors. So it's a very small number of professors. So around 2 years before COVID, I was in the gala dinner, the black tie dinner with the National Academy. And I was in the dinner, in the table with 11 CEOs, right? It's a table for 12. So me and 11 CEOs from Bechtel, from large construction companies. And they're all complaining about that you're not teaching software to our students, that they were coming to their companies and, for example, they didn't know Primavera, that you're not teaching them well how to do scheduling with Primavera. And then I asked them, and this is why learn to learn is so important. I asked them, who in that table believes that we would be using Primavera and those scheduling tools 10 years from now, and that we would not be using an AI tool that would predict the duration and the activity sequence? All of them looked at me that said, obvious that in 10 years, everything it's going to be data driven. It's not going to be done by experience like we do today. So then I asked them, why you want me to teach my students to be obsolete? Okay, why you want me to train them to use a software that you know that it's not going to be used 10 years from now? And they said, because you need them today. So industry, it's very concerned with today, what they need today. And João discussed this with me a lot because he's seen this side of industry. They want what they know now. And 5 years from now, if things change, they would fire you and they would hire the new students that we graduate. So the most important thing is not to think about just software. It's to think about what is the knowledge that I need to have to be able to evolve with the industry, not to be fired as obsolete 5-10 years from now. So yeah, what companies are using software in the US are Primavera for scheduling. They are using Revit and other modeling tools. And again, João, you can add about that. What are the softwares that you use in your daily operations?
Data operation
You can just give me a quick list if you can, Joao. We are going to move on to the next question afterwards. If you have any short list of software.
Yeah, the softwares that I use every day is CAD, Revit, Navisworks, and pretty much in scheduling Primavera, budgeting, they use Assemble now. But really, don't get fixated on what software you should learn. Software is super easy to learn. Just go to YouTube and get it done. That's the way that I see. You have a lot of tutorials out there for software. Software is easy to learn. Concepts are hard, and doing those things are hard.
Okay, so when you hire, I don't know, Joao, are you doing any hiring at all?
Yes, I did some.
So what do you look for in a person that you are planning to hire? What qualities are you looking for?
How can I explain this? I look for someone smart. I don't care if you can get the job done. I care if you can be smart. You can give valid points. I don't want someone that will agree with me. I want someone that is going to give their opinion and say what they think. So like we can both have a discussion to build a better point. If I wanted to hire someone that thinks just like me, I'm not going to hire because then I don't need. I just have myself. That's what I look for at most. And core basics, institution ideas, basics ideas of management, like do I see this person, can they deal with people? Because on the end of the day, civil engineering also has a psychological component where you're dealing with a lot of people, and people are not easy. So I don't want to hire someone that doesn't know how to handle people. So those things would be the core priority for me. Training, software training, that's we can do. The basics of management, the basics of how to deal with people, how polite you are, how smart you are. Can you think outside of the box? Can you at least think? Are you a machine or are you human? Those are the things that I would say that I look for.
Wonderful. So someone asked, does LEED and USGBC professional certificate, will that increase job opportunities? Do you know what those are?
Yeah, I know what they are. Do you get to go, Lucio?
Go first, and then I go second.
Yes and no. I think it really depends on the construction site. I think it's way less marketized now than what you should be. So I wouldn't be so fixated on certifications too. If you want to go for it. It's a great tool to learn, but it's not as, in my opinion, as big as it used to be, at least on the job market. I don't know what you think, Lucio.
I think that this is very related to your previous question. Okay? Being certificate, for example, LEED certification doesn't mean that you have any intelligence at all. Okay? It's almost like a box approach to getting points. Okay, so it's the opposite of having any reasoning about intelligence. Okay, So yeah, it's a certificate that the guy can memorize, he or she can memorize something and get a certificate. Would not demonstrate that level of intelligence that João was talking about. Obvious that yes, there are some companies that would like to have some staff that have certification, could help you get a job. But I think that I saw people posted questions about sustainability and buildings and all those things. I think that the problem is much bigger than just building a bicycle parking in a building, okay, or having a high-end AC system. Okay, João did during his PhD research. We learned a lot in the last few years that you can have two very sustainable buildings and they have completely different energy consumption because you have something that makes things very complex. That's called the human. Okay, whoever lives in the building, the behavior of the person in the building, it's much more relevant than the building characteristics itself. So there are a lot that you have to do in sustainability to learn about what you call human building interaction. This is the research from my colleague here, Burçin Besserit, and trying to understand the behavior and how you change behavior. This is when you're really going to achieve sustainability, when people are sustainable, okay? Not when they are, you can have the same thing with cars. You can have low consumption cars depending who drives it, okay? A heavy foot can make that car consume a lot of fuel. So again, human, it's a big part of this discussion. And I don't think that lead is an answer. I personally don't think so.
Okay. So I guess we have a bunch of programs that we have at USC. So I'm just quickly going to show a couple of slides, and then we'll go back to our discussion. Let me just give me a second. Okay, so very quickly, these are some of the programs that we offer within the School of Engineering for civil engineering. And the advanced design and construction technology. Are these any of the programs would you recommend for a student who wants to learn some of the futuristic things that you talked about?
I would say the advanced design and construction technologies, the one that we are bringing, robotics, AI, and machine learning. I would say that this is the one that it's pushing the envelope just for construction. The structural engineering program has those topics in structures, and the transportation systems has in the transportation area. I would say that the construction engineering and management, the construction management are the one more traditional with industry teaching, as I said before. And the civil engineering in general, it's basically more for people that companies come up with a specific, they can customize they can take some class in transportation, some class in structures. There are some companies that fund their own students, but make a list of classes that doesn't match with our program. So we allow them to customize the program through the general.
Okay, so yeah, so the advanced design and construction technology program sounds pretty exciting. So I'm just going to share, if anybody is interested in any of these programs, you can visit our website, www.uscengineer.com, and get some information over there. You can write to us, and of course, do follow follow us on social media. So coming back to our questions, there was one question which was asked by a lady. She said, "Is civil engineering is it an appropriate profession for girls?
Our department, 70% of our students are female.
Oh, and I can say this, the best coworkers that I have and one of the best boss that I have, they're all females. Like, I wish most of our males were females because they are much better than the guys, honestly.
And
Yeah.
I have my mom and my three sisters are engineers. So my mom she already passed away. She graduated more than 60 years ago, 70 years ago. She was an engineer already. So yeah, I don't see any difference. We have around in the undergrad level, we are a civil and environmental engineering department. We have around 65% of our freshman class is female, and in the environmental side, 75% it's female. So you have much more female than male students at the undergraduate level. At the master's level, because it's international, other countries still have a smaller number of female students. So they feed the students from India, from China. I'd say that there we are probably 60% male and 40% female at the master's level. But at the PhD level, it inverts again. The majority of the PhD students are female too.
I wanted both of you to give a short piece of advice to the people in the audience, mostly undergraduate students. So Lucio, you want to go first and tell them, in this time where, the industry may have been hit by COVID, if they start their education by the end, should they go for it now? Should they wait a little bit? What is your recommendation?
I think that because the industry is changing so fast, you can never get comfortable. You have to learn how to put 3 to 4 hours every day in your life to study for the rest of your life. And so if you know how to do this, you are comfortable. Just keep moving. If you don't know how to do this, and if you're lost, you need to go back as soon as possible. Find some guidance on how to learn and start moving, because the industry is moving too fast. And in 4 or 5 years, you can get a complete obsolete.
So would you, if someone came to USC Viterbi, would you teach them how to learn?
I think that the classes are, as I said before, the classes are project-based, so they are homework-based. So if the student doesn't learn how to learn, he fails in the class, because in the lecture I give ideas, topics, and then I give a lot of chapters and books and readings that the student has to read, and then I give a huge assignment almost every week that the student, if the student just attends my class, would never be able to answer the assignment that I give in the end of the week. So it has to go much beyond to library, to search, to talking to people, to be able, and that is, I'm not teaching them how to learn. I'm not teaching them how to learn, but by expecting them to be able to find a way of answering things that I haven't taught. They are in an indirect way learning how to learn. João can tell that because he took my classes. How little I teach according to what I ask the students to ask. So the most common question that I had, the students after the exam said, "But you didn't teach that." I said, "So what? What's the problem? How could you ask that question in the exam? You never thought it." I said, "Yep. Yeah, I've learned it."
So, Joao, this question is, I guess, for you. As an international student, you've kind of gone through what many of these, the people in the audience are contemplating. What is your advice to them?
Do your part. Always do your part. Doesn't matter. Forget the others, forget comparisons, forget everything else. Always do your part. As long as you're doing your part, for what I learned with life, everything has a way to fall into places. But if you don't do your part, no one else gonna do for you. That that is the most important thing. And if it is studying, is studying. If it is watching tutorials, working late, doesn't matter. Do your part.
Yeah, sounds good. Just knowing the state of construction industry in India and the education, I think it would be good for students to come and study and learn all the latest technologies in the US, and consider doing your master's as soon as possible when the economy is still not doing so good. So hopefully by the time the economy turns around, you would have finished your master's. So that probably is a good advice from my end. So this has been wonderful.
My advice through my travels through India is that a lot of people from India wants to stay in the US and get jobs in the US, reading how can I get a job in the US. There is so much to be done in India. India is putting so much effort in computer science. The top minds are moving into computer science. They are not going to solve the problems that India has. They are not the professionals that are going to bring water to everyone, the roads that you need to build, the metro systems. You have so much thing that the country is building and needs to build in infrastructure, and I don't see India putting the right value to those professionals. It's everything about computer science, and what can change that country into the power that it has to be one of the top countries in the world is the infrastructure that needs to be built. And this is going to be done by civil engineers, not by computer scientists. So
right.
I think that there is a lot of opportunities in India for top civil engineers, and I think that's an exciting place to be. It's an amazing country and a lot of things that you guys can have a huge impact. So I would not like to see everyone coming to the US and stay in the US. I think that you guys can have a huge impact in India too.
No, I think a great combination would be to come study in the US, learn some, get some real life experience in the US, and then come back and bring those skills back to India would be fantastic.
And just to say something is that as a civil engineer, you don't choose where your construction site is. You go where your construction site is. So it doesn't matter really if you stay or not, in my opinion.
Yeah. No. So that, I think, was a fascinating conversation. I think there was a lot of learning for the audience. Thank you to both of you for joining us today. I appreciate you taking the time.
Just one thing, I see some questions confused about course requirements and this. So the best person to ask, there is a staff in the department, Christine. You can go at the site and look. She is the advisor for all the graduate students. She knows about all the sequence, all the requirements for all the programs. So Christine C. So I would strongly recommend. I can type her email here. This is the person that can bring all the information that you need about processes, application, sequence, requirements.
So, Lucio, we will be doing other sessions for students who are thinking of applying. And so we do plan to do one towards the end of the month. And we will be contacting everybody who registered for this event and reaching out to them. And we can help them with the application. And then once they are admitted, perhaps Christine can help them.
Okay.
Yeah. All right. So, thank you all for joining us today. I appreciate it. I hope you enjoyed the conversation and I hope you found it enlightening. Thank you, Lucio. As always, it's a great learning, great to just hear you. You learn a lot. And Joao, wonderful to have you as well. Thank you very much.
Thank you.
Thank you, everyone. It was a pleasure. Have a nice evening, and we are going to have the whole day ahead of us here. Bye.
Bye.
Wow. Thank you.